Okay. I hope the screen is visible. Shall we start? Right. So we will take up one more example. Over here, you will find that there are three rigid bodies. Those are connected to each other with the help of the rope system. Okay. This is a complex situation, you can say. There is one more pulley over here, and this is like this. Okay. Slopes are given. This is 3 vertical, 4 horizontal, and again this is 3 vertical, 4 horizontal. These are the rough surfaces. This is inclined, this is also inclined, and this is vertical. Oh, this is not surface, this is thread. Sorry. Over here, there is one weight which is attached. This is 400 Newton. This weight is 800 Newton. And one more weight of 1000 Newton. It is attached over here, like this. Okay. This is 1000 Newton. So there are three blocks, you can say, and you can name them as block A, B, and C. Okay, you are supposed to identify the acceleration of each body and the tension in the cord supporting A. Okay. Moreover, the coefficient of kinetic friction, UK, this is 0.2. This is given under B and C. That means mu k over here and mu k over here, they are the same, 0.2. Okay? This is free. This is not in contact with the vertical surface. This is free. So have you understood the problem statement? What you are supposed to identify? Acceleration of each body and tension associated to block A. Now just let me know what will be the value of tension over here. Let us speak in terms of capital T itself for time being. So what will be over here? It will be capital T. Okay? Now just observe, this rope is wound over this pulley. Then it goes like this. Then it is wound over second pulley. It goes like this. Right? Then this rope is wound over the third pulley and it goes like this. Correct? So if I consider this complete thread which is wounded over these three pulley systems. So don't you feel that this value of tension over here, it will be capital T, over here it will be again capital T, and since this is continued over this third pulley, then the tension over here shall again be capital T. Why I am saying that it is capital T? Because the pulleys are frictionless. Nothing is mentioned about the pulley, whether it is having some friction or not, but over here it is frictionless, right? Accordingly, what should be the value of, let's say, P over here? So last time we had discussed, if I consider the free body diagram of, let's say, this portion only. So from here, the free body diagram is something of this sort. This is P, this is T, T. And if I consider this to be the axis, okay, and since we are saying that it has got internal force, that means everything is in equilibrium. Summation of force in x direction equal to 0, and therefore P will be equal to 2 times T, isn't it? So the force P over here can also be expressed in terms of tension force, that is 2 times T, right? So this becomes a free body diagram of uh, as far as the internal force is concerned. Now let us try to find out the direction of motion of each block. While doing so, what you are supposed to take care? You are supposed to consider a few things. First of all, you consider block A, है ना, to be at rest. Okay, we will consider that block A to be at rest, and we will neglect the friction, neglect friction for all the other blocks, that is block B and block C. This is what we will assume. Based on this assumption, let us now try to find out what should be the final direction of motion of each block. In that case, since I am assuming block A to be at rest, I will draw the free body diagram for it. So it is very much clear from this free body diagram that force T will be equal to 400 Newton. Am I right? Now, based on this situation, can I not say that if I draw the free body diagram, and what I am saying, I am neglecting the friction. For that, I will draw the free body diagram for, let's say, B, and then FBD of C. Okay? Let us attempt that. Right? And this is force. Okay? I will consider this axis. Okay? This is 2 times T. Fine. Then there will be normal reaction. Let me consider it to be NB. Right? We are not assuming any kind of frictional resistance right now. Okay? So therefore, the opposition force will not be there in the picture. The self weight is of 800 Newton. So these will be the components. The angle, whatever you will get, it is 36.87, I suppose. Please verify. 36.87 will be the value for the angle. And therefore, you will find that these components shall be 800 sine of 36.87, and this is 800 cos of 36.87. Cos and sine components Fine. This is 2T. These are the forces which will be available when we neglect the friction force, isn't it? Now, similarly, the free body diagram of C. This is 1000 Newton. Okay. Again, the angle will be same. Correct. This will be 1000 sine component, sine 36.87. This is 1000 cos component. True. Then this is normal reaction C. Then there is one tension force which is associated with this block C, which is capital T. Again, we are not assuming any kind of friction over here. Okay. So for these two figures, what I can say is I can identify the net force which is actually acting on these two blocks because I have identified this T value by assuming block A to be at rest. So in such situations, we are supposed to assume any of the blocks to be at rest, find out the tension value associated to it. Then, with respect to that tension value, identify the net force which will be acting on the adjacent or the connected bodies. So in our case, we have got two bodies for this numerical, this one and this one. So let us try to identify the net force. Net force on block B. So you know the net force which will be responsible for the motion of this block, it will be in this direction, that is x direction. So I will assume this to be positive x upwards, and this is again positive x. Opposite to it shall be negative value. Okay? So this is the x-axis, this is again the x-axis, and these two are positive directions. So for block B, the net force will be in this direction. I mean the force which is responsible for the motion of this block. What it will be? Net force acting. It will be 2 times T, which is positive, minus 800 sine of 36.87. Anything else other than these two forces? So you substitute the value. T we have found out to be 400. Okay? 800 sine 36.87. How much value do you get? How much value do we get? Yes. Please identify this value.
319.99.
Okay, so let's say 320 Newton. Okay. So this is when we have neglected the friction. Okay. Now, if I consider the frictional resistance, if friction is assumed, okay, that is FB will be equal to mu K into NB. In order to calculate NB, apply summation of force in y direction equal to 0. Summation of forces in y direction equal to 0. Therefore, NB will be equal to As from the figure, it is very clear. 800 cos of 36.87. How much value do we get?
640.
640. Okay, this is NB value. Therefore, FB value will be now equal to zero point 0.2 into this 640. That is 128 Newton. And 128 Newton is very less compared to this 320 Newton. And if you observe, this value comes out to be positive. So what do we interpret from this? Even this frictional resistance of 128 Newton is not sufficient enough for this block to move. It will not stop it moving in the upward direction. Am I right? Because the net force which came out, it was positive, and we have assumed this to be the positive direction. So this block will be moving in the upward direction. And 128 Newton force, which is the frictional resistance, this is not sufficient enough to keep this in position, and it will continue moving in the upward direction. This is what we will interpret, right? So we have understood the direction of motion of this block B. Similarly, we can find the direction of motion of block C. For that, let us find out the net force on C. Now again, you can see this positive, this x-axis is responsible for finding out the net force. Okay, so what it will be? So I have assumed this to be positive. T. This is negative, so minus 1000 sine 36.87. Okay, substitute the proper value. This is 400 minus 1000 sine 36.87. Find out the value. How much do we get?
Minus 200.
Okay, minus value. Minus 200 Newton. Now I will assume friction. Consider friction. If I consider friction, F suffix C is equal to UK times NC, right? So to find out NC value, summation of forces in y direction equal to 0. Okay. So NC comes out to be 1000 cos of 36.87. How much is this value?
800.
800. So this 800 value, okay, this is more than this. What should we interpret now? No, sorry, minus it. So this is NC actually. FC will be equal to 0.2 into 800. Sorry. So this is 40 Newton, am I right? Oh, no, not 40, 160. Sorry, 160 Newton. Okay, 160 Newton. And this 160 Newton is still less than this 200 Newton, right? And if we check the direction, this comes out to be negative. That means the net force which is acting on block C, actually it is in the downward direction. Do you agree? Isn't it? The net force which is acting, it is negative 200. That is, it is acting in the downward direction, opposite direction, you can say. Okay? And this frictional resistance is insufficient to hold this block in position, and this will continue moving in the downward direction, right? So we have understood the direction of motion of this particular block. We have also understood the direction of motion of this block. We can assume the direction of motion of this block because you can see this is not connected to any of the parts of the rigid body. So what we can say, we can assume, and let's say this is moving in the downward direction. Let's assume that, right? So fine. So well, I will rub this part. So we have decided the direction of motions. Now with that decision, we will now consider the frictional resistance and we will draw the final free body diagrams for all the three figures. Finally, in the sense we will have to consider the resistance also. And with respect to that, we shall now be calculating the acceleration values and whatever is asked tension. Okay. This is 800 sine component. This is 800 cos component. Okay. This is NB. Now this was moving in the upward direction, right? So let me assume displacement of block, sorry, this is B. Displacement of block B like this. Inertia force shall be opposite. Okay. What will be the magnitude? I will directly write down 800 divided by G. That is W by G into AB. Correct? Frictional resistance, since it is moving in the upward direction, the resistance offered shall be downward. What will be the magnitude? Mu k times N B. We have already found out NB was 640. This came out to be 128. 128 Newton. Take. Then this second block A. Okay, this is 400 Newton. This we are assuming to be moving in the downward direction. As a inertia force shall be upward. Okay, this will be 400 divided by G into AA. Okay, and this block C. Thousand Newton. This is T, then these are the two components, 1000 sine component, 1000 cos component. This is NC. This was moving in the downward direction. Correct? We have identified the movement and the inertia shall be upward. That is 1000 divided by G into AC. There will be friction resistance which will be offered. Okay, since it is moving in the downward direction, the resistance offered shall be upward. What was the magnitude over here? 160 Newton. Okay. So this is the complete free body diagram of these three blocks, you can say. Now, with respect to this, develop kinetic relation. First of all, kinetic relation, that is the total internal work done should be equal to 0. 2T into SB, whether it is positive work done or negative work done. Yes, what it should be? 2T into SB. Positive work done because both are in same direction. Okay. Then plus T into SA. This is negative work done. Why? Because both are in opposite directions. And similarly, T into S suffix C. This is again negative, equal to 0. So there are three terms, as you can see from this equation. There are three terms, and the relationship shall be 2 times SB minus SA minus S suffix C equal to 0, and in other terms 2 times AB AA AC equal to 0. Make use of dynamic equations of equilibrium. Let's say for block A, for block B, A and C, like that. Summation of force in x direction. अब सब x direction का ही, इस केस में x direction, इस केस में y direction, right? So I will formulate the equation. You are supposed to solve and find the relevant answer. This is minus plus 2 times T minus 128. This is for block B I am talking about. Minus 800 by G into AB. All the things are covered. Equal to 0. Okay? This is for block B. For B. Then for A, summation of forces in y direction equal to 0, because there is no force in x direction. So what will be the value? It will be T plus 400 divided by G into AA minus 400 equal to 0. And for C, summation of forces in x direction equal to 0. So see, I am assuming this to be positive, this side. So T minus 1000 sine 36.87 plus 160, this term, and plus 1000 G AC equal to 0. So you are supposed to take help of this equation and you are supposed to solve these three questions accordingly. Okay? I will give this as your homework. You can check the values for AA. It comes out to be 1.27 meter per second square. AB, it comes out to be 1.084. And AC, this is 0.9. Tension value 348, 348.2. This is the tension value. You can verify this. Okay? So based on the free body diagram, You are supposed to identify the motion of the blocks. Okay, you are supposed to assume certain parameters which I have told you, and accordingly you are supposed to proceed, right? Now we have discussed the portion of dynamics wherein the two or more rigid bodies, they were connected to each other. Now we will discuss when the rigid bodies, they come in contact with each other with some velocities and some acceleration values. What is the what are the different parameters in those cases which we need to take care of? Okay, for example, let's say that there is a rigid body and it is acted upon by various forces in different directions like this. So as per the Newton's second law, what we say that unless and until some external unbalanced forces acted upon, the force is equal to mass into acceleration. Over here, what I can say, the resultant of forces is equal to mass into acceleration. It is one and the same thing. Okay. So what I have done, I have replaced this summation of forces with respect to one effective force, which we call it as the resultant. So it is mass into acceleration value. Or if I want to express this mathematically, okay, I mean in more uh, divided form, what I can do is I can multiply both the values, both the terms with the elementary displacement. See what happens by the virtue of these forces. This rigid body may get displaced by some amount. Okay, the direction is not known right now. So let us say that this is the small displacement, elementary displacement, with which I am multiplying this equation on the both sides. Okay. What actually I get over here? I will rearrange the terms, and with the rearrangement, what do I get? That this A into ds can also be written as V into dV. You will agree, isn't it? Because since A into ds is equal to V into dV. Okay. This is what we have considered for a small finite distance. If we want to check the response of this rigid body for a very large area, okay, and for large displacement value or some finite which is not zero value, then what I can do, I can integrate this value from some initial displacement which was at zero level or at rest to some finite value of s. Similarly over here, because of the displacement, that body must have gained some kind of velocity, right? So let me say that some initial velocity to some final velocity. Okay, so I will try to find out the value associated to it. What it is, R into S is equal to W by G. This is common term. It will be V2 square minus V1 square. Am I right? And whole divided by 2. Or in other terms, R into S is equal to half W by G or W by 2G into V2 square minus V1 square. This equation is known as the work energy equation. So because on the left hand side you can see this equation is nothing but force into displacement, that is the work done. Whereas on the right hand side it is the equation related to the kinetic energy, or you can say change in the kinetic energy, right? So this is known as work done is equal to change in kinetic energy. Okay. So this is equation pertaining to the what you can say body which is subjected to force. So this is the initial condition before the rigid bodies, they come in contact with each other. Now let's say this again, this equation, which is R is equal to mass into acceleration. Uh, Acceleration term can be expressed as dv by dt, isn't it? Change in velocity, or R into dt is equal to m into dv by rearranging the terms. Okay. Now you can see over here uh, for small duration, this is time. For small duration, if the resultant or the forces are acting on the rigid body, uh, on the right hand side, what do we get? M into dv. Okay, that means this is small velocity into mass. This term is actually the momentum value. Okay, and this term is known as impulse. Okay, impulse is nothing but the force which is applied for a very small duration, but whose impact is very large. So this is the impulse, and on the right hand side, this is the momentum. Okay, so this equation, whatever we have found out with respect to rearrangement of the terms, this is known as impulse momentum equation. It can be expressed in a larger scale, on a larger scale, by integrating this to 0 to t r into dt is equal to, again, some initial velocity to some final velocity. Okay, so let me say m into dv. So what do we get? R into uh, t, r into t is equal to m into v2 minus v1. So again, over here we find change in the momentum. If we express this, this is nothing but change in momentum. And this left hand side of the equation, this is known as impulse. So this equation is known as impulse momentum equation, right? Okay. Now see, these terms are essential because we are talking, we will now be discussing about the two rigid bodies, two or more rigid bodies when they come in contact with each other. You must have studied about the Newton's cardinal, I suppose. In that, there are uh, various strings and there are balls which are arranged like this. If you pull the this particular ball and you leave it, okay, free, what will happen? This will collide, and it will be interesting to know that instead of the movement of this or this ball will get displaced, and it will get displaced by the same amount, or by the same angle, you can say theta, by which this first ball was displaced, right? The final position will be like this, right? And then what will happen? This has struck this second ball, okay? By the impact, what will happen? This ball will get displaced. After a moment, it will come back, it will strike this ball, and you will find that this ball which was at rest, this will get displaced. So this is known as actually the energy which is conserved at this point, and this law or this principle is known as law of conservation of momentum. This you must have studied. Okay, so according to this law, what it says that initial momentum is equal to final momentum, or the total linear momentum of a rigid body or system of a body in any one direction remains constant unless it is affected by some external force in that direction, isn't it? So if we consider V1, V2, V1, V2 with the initial velocities of, let's say, two bodies, for instance, then V1 dash and V2 dash be the final velocities. Then, as per this equation, it says, or rather the principle, it says M1 V1 plus M2 V2 is equal to M1 V1 dash plus M2 V2 dash. ठीक है? Right? So this is the law of conservation of momentum. Then we will see what are the other associated terms when two bodies they collide with each other, and based on that, how to solve the numerical associated to the dynamics part. Okay, so I will stop over here, and we will continue our discussion in the next class. Okay, you people can leave.
Thank you, sir.
Thank you.